So the first thing that we get assessed on in terms of the application of integration is the area under the graph. So that's area bounded by a graph. And the second thing that is we cover is the volume of rotation. Now, both of these areas about when you talk about is about x-axis, y-axis areas, and also the bounded areas. So bounded areas means they are bounded by the two different functions. Similarly, we have got volume of rotation formulas about x-axis, about y-axis, and then mostly the type of bounded question don't come, but like you might get the questions where it is bounded volume, bounded volume. So let's take an example of each, obviously. What does the area under each graph, how do you find an area under each graph manually first? So when you have area about x-axis, if it's a simple function, which for which the part of the graph is about x-axis, let's say this is A and this is B here. The area under the graph that you talk is, this is the function that we talk. So when you have this function, which is, let's say f of x, y equals to f of x here. Now, if I integrate this function f of x from A to B, that's my area. Now, let's say when I have a function like e raised to x plus 7, e raised to 2x plus 7, and I want to find out what's the area bounded from 0 to, let's say, 2. So let's say I want to find this area. So in this case, what I'm going to do is just simply integrate e to the power 2x plus 7 dx from 0 to 2. So that's the area straight away. So when you find this answer now, so it'll be e to the power 2x plus 7 over 2 from 0 to 2, because you divide with the coefficient of x here. So eventually what happens is that if you plug in x as 2 here, so you get e to the power 4 plus 7 is 11 over 2 minus e to the power 7 over 2. So this is the area under the graph of this function. Now, when you talk about the area bounded by the graph across y-axis, now let's say this is the area that I'm finding out, this part something. So now in this example, let's say instead of this particular area, I wanted to find out this area. Now what might happen is that, okay, you might think, okay, I found out this area, which is this, and I can find the area of this rectangle and subtract them. That's also okay. So if you got, this is this area and this length and this width you already got. So you can find the area of this entire rectangle minus area below the x-axis. But sometimes the question is where you have to explicitly find out the area about y-axis in that case. So to find out the area about y-axis explicitly, what you need is that suppose if there is a function, which is, let's say the graph is like this, and let's say you're finding out the area bounded by the curve on the y-axis between, let's say, y1 value to y2 value. So what we do is, in this case, we just integrate from y1 to y2 and x dy. Now, this is the area formula across the y-axis. Now, let's say for this question, when I had to find this area. So first what I would do is I would make the formula, the x as the subject to the formula. So let's say I've got e to the power 2x plus 7. First I'm going to make is the subject for formula will be, I'm going to make change the subject as it'll be ln y equals to 2x plus 7. So it'll be x will be ln y minus 7 over 2. So this is the subject. Once x is the subject of the formula, then you're going to integrate from y1 to y2. So if I integrate ln y minus 7 over 2, you could use by parts and all those stuff. But right now I'm not doing that. You can use, now your y1 limit is basically you want to put when x is 0, what's your y value? That is nothing but e to the power 7. And when x is, let's say this value is 2, corresponding y value, what it is. So if I take x as 2 here, it is e to the power 11. So just integrate this either manually or using calculator to find out the area bounded by this directly about the y-axis and the curve. So this is how you find out the area about x and y-axis. Now the other puzzle is that what happens is that sometimes the area is let's say below the x-axis. Now for example, some part where your area is something like this, that okay, you are given the function as a, B, and C, and you're finding out, let's say, bounded area by the graph and the x-axis and the line x equals to 0. So in such cases, what happens is that firstly, like this integration when you do, let's say this is 0, this is my f of x. So when you integrate this function f of x from 0 to a, uh, the, the area is a1. Let's say this area, whenever it is above x-axis, is positive. Now, if I integrate from, let's say, a to b f of x, this value, that numerical value, will get a little bit negative. So it'll be some value, which is, let's say, a2. Then the actual integral value will be negative a2. Now, third one is, let's say, this is a3, which is area from b to c, because it's above x-axis. So you get a3 straight away. So actually, if I integrate from 0 to c the function f of x, my answer is nothing but a1 minus a2 plus a3. So this is not the area, because you know that the area is never negative. So what we do is, in that case, we actually take a call on to make the second area absolute value. So the actual thing what we do is, we integrate from 0 to a f of x, and then plus absolute value from, let's say, a to b of the integral f of x, and because this answer is negative, so that's how it become positive, and then plus b to c, because you know this answer is straight away the positive answer. So this answer which comes negative, we make it positive, then you add to the original amount. Now, so this is how you basically interpret such area-based question. I'll just take an example on this. Now consider that what I'm giving is, let's say, a part of the graph of, let's say, y equals to sine x. Now this point which is here is, let's say, this is 2 pi by 7, 2 pi by 3, sorry, 2 pi by 3, pi by 2, uh, pi and 3 pi by 2. This answer is 3 pi by 2, this area. And I wanted to find out what's the area bounded by the graph and the x-axis and the line y equals to 3, x equals to 3 pi by 2. So when I integrate this, directly if I integrate sine x function from 0 to 3 pi by 2, this answer is not the area. So this is not the area, because this is actually getting cancelled. Because if I integrate directly, some part which is below, they, instead of adding, the subtract, because naturally you're adding a negative value. Integration just sums up the value. That's what it does. So you whatever this value you've got minus this value will happen. But actually what I'll do is, since you know this answer is pi, 180 degrees here. So what we do is, if you integrate from 0 to pi, the value of sine x, and then plus you integrate from pi to 3 pi by 2, the value of, let's say, sine x function. And you know this answer is going to come negative, so you be careful and make the absolute value of this function. So this is what is the general idea about finding the area bounded by the graph below x-axis and some part above x-axis.